Hello everybody, in this video I will be talking about hashing. Hashing is the method of mapping given data to the hash table. Let's suppose that we are having a list of integers like this. This list of integers is stored within the integer array and we are having a table of size 20, that is the integer array. Now what we have to do is we have to map this value to this table. Okay, now how we can do this, let's see. Okay, now in case of the hashing, we will be having the hash function and we will consider these as the keys, and we will be passing, let's suppose this is the hash function, we will be passing these keys to this hash function and it will return one value, that is the hash value, and that hash value becomes the slot within the table. Okay, slot within the table. Now how we will be doing the hashing? Here we will be taking prime number and we will be using division method. Okay, in the division method we will be dividing these keys by prime number. Okay, now here how many numbers are here? We are having 9 numbers. Now maximum is 18. Now what I do is I will be taking 13 as the prime number and I will divide this individual's number by 13. Okay, now let's see what will happen. Let's take the first number 5 divide by 13, that will give us remainder 5. So this is the slot, this is the position within the hash table. So this 13 will be stored here. 13, no, this is the 5, this 5 will be stored here. Now second value, this is 17, we will be dividing 17 by 13. Now we will be getting the remainder 4. Now 17 will be stored in this position. This is the fourth position, fourth index of this table. Similarly 18, that is the another number, that divided by 13 gives us the remainder of 5. Now this 5 is stored, should be stored here, but in this position there is already element. So this situation is called hash collisions. Okay, this is hash collision. Okay, means two keys hash to same position. There are different ways to resolve this hash collision. What we can do is we can store this value to the next empty position of this hash table. Okay, when we divide this 18 by 13 we get the remainder 5. So this is the slot where 18 should be stored, but that slot is already occupied by 5. So what we do is we'll increment this slot by 1 and check if this position is empty. If empty, 18 will be stored. In this case this is empty, so 18 will be stored. If this is not empty, then we will again increment this value, and until we will be incrementing these values until we find the empty space within the table. Okay, so this is simply a linear proving. Okay, linear proving, this is the method using which we can remove the hash collision. Okay, when hash collision occurred, in that case we can resolve, actually not remove, we can resolve the collision using linear proving. Okay, now let's see how to implement this hashing in Java. Okay, I'll be writing a class. Okay, first, now let's start. Now let's import one package, import java.util.asterisk. Now let's create a class hashing. Then let's declare array, int array. Now this is the list we have to map. Then let's have a table. Then let's have the divisor, that is the prime. Now let's declare the constructor public hash. Then let's get the list from user. Table, then this dot array is equal to arr, then this dot table is equal to table, where what I will be doing is I will be filling this list, this table, with some values which will not occur within the list. Okay, so arrays dot fill this dot table with minus 99. Let's suppose this value does not occur within this list. Okay, so this will indicate the empty position within the table. Okay, so if the value, if in some cell the values are 99, that means that cell, that slot is empty. Okay, so in order to indicate the empty value, I am using this minus 99, and suppose that this minus 99 will not occur within this list. Okay, now let's write the hash function public void hash func. Now so provide a divisor here, the prime number. Now what I will do is I will declare one integer variable, another position. Okay, position. Okay, now what I have to do is I am using the loop for I is equal to 0, I less than array dot length. This is the original array, original list, I plus plus, then position is equal to array I modulus. Okay, I have to assign this prime. I will assign this prime here. Dot prime is equal to prime. Okay, we have the class member variable prime here. Okay, so I am assigning whatever value been passed to this prime by prime. Then what? Okay, this will give. Okay, now here initially what was that? That was the 5. The 5 was divided by 13. So this is happening here. 5 divided by the prime number, we will get the position. Now what we have to do is we have to check if table position is equal to minus 99. That means this is the empty slot. Okay, what we will do, we will table POS is equal to array I. Now whatever I initially talked, 5 when divided by 13, the remainder will be 5, and with this post will contain this 5 value. Now this 5, in the index 5 of this table we are storing this value 5 because there is no value. Minus 99 means it is empty. Okay, now that's it. Now what we have to do is, okay, then we have to else. Okay, else if this position is not empty, then what we have to do, we have to do the linear probing. There is the quadratic probing also, but here I will be doing the linear probing. Okay, so we have to do linear, I have to write this, define this method, linear probing. Here I have to provide this position, this value, then I have to provide the element array I. Okay, linear probing. Okay, now that's it. Now that's it for this method hash function. Now I have to define this linear probing. Now what I have to do, function linear probing. Initially it is having position, then int, let's suppose it is the element ele. Okay, now let's define one variable I is equal to POS. Okay, now let's loop through this. If I is equal to less, no problem, if I less than table that length, if I is less than table dot length I plus plus. Now I have to do, okay, I is actually I plus 1 because we have already checked it here. Okay, position is not empty, so I have to increment position by 1. So what I have to do, table I is equal to minus 999, then table I is equal to ele. Okay, then I have to break this loop. Simple. Okay, 1 2 3. Okay, okay, now what I am doing here is, let's suppose if this slot, when we checked 18 and divided by 13, we got the remainder 5. So this is the 5, and this position is already occupied by some element. So what we have to do, we have to check whether the succeeding space, there is any empty space after this or not. So we have to increment this value by 1. So what I did is, initially I took here the position, and in the loop I am incrementing position by 1. So if this position is 5, then I will become 6. If in the position 6 there is minus 99, that means it is empty. We will assigning element to that place and will break the loop. If that position 6 is not empty, then I will be incremented. Now it will become 7, and it will check in the 7th position whether there is minus 99 or not. If it is minus 99, element will assign, and this will go on, okay, until it find the empty position. Okay, so in this way we can write the linear probing method. Now let's write the method for finding the position of the element. Okay, why I am writing this function here? In the Java, this is not the function. It's in Java, I cannot write the function. It should be public void. Now I have to write public void, let's suppose find int element. Okay, now what we have to do is, now we have to find the position of element within this table. Okay, so let's declare variable I. Then okay, we need this another position also. Now position is equal to ELE divided by prime. Now here this prime is a variable of the class, we can see. So this prime which I have assigned here is accessible to all the methods of this class hashing. Okay, so if, now what I can use the loop here. For I is equal to position I less than table dot length, then I plus if table I is equal to element, then simply I will be displaying message here, system dot out dot print found at, then specify the position. Okay, simple. And this, if we found, we will have to break this loop. Okay, then okay, I can, if I is equal to table dot length, then system dot out print ln not found. Simple. Close this. Okay, this is the closing, this is the closing of the class. So in this way we can write the find method also. Okay, what is happening here is in the find method we will passing the element and we will get the position using this prime. The prime is the same value which we have used to store the data of the array within the table. Okay, so in this case, if we have suppose prime as the 13, this value will become 13, this will become 13, this is also 13. All of these array elements will be divided by 13, and modulus and the position will be generated, and we'll store values within the position of that table. Now here what is happening is element is divided prime. This, suppose this is 5, well this is 13, and our 5 modulus 13 means position is 5. So initially we are assigned I is equal to, we have assigned position to I in the for loop. This I, this is 5 less than length of the table, because the size of table is 20. So in this 5th position there is 5, 5 is equal to 5, 5 is found. If it shows 50, 18, okay, now what will happen is element is 18, 18 divided by prime, that is gives 5. This will start with 5, 5 is less than 20. So in the 5 there is no 18. Okay, so this will not be evaluated to true. So I will be incremented, this will become 6. In the 6 we are having 17 actually. Okay, we are having 17. No, we are having 18. Okay, now we are having 18. So 18 is equal to 18 found. Okay, so in this way we can hash the values to the table, and we can sort the hash value within the table. Okay, now okay, let's see how to write the driver program for this. Okay, Okay, let's suppose class has demo public static void main then string param. Okay, now let's declare array arr is equal to 5, 17, 18, 13, 14, 4 and so on. Okay, let's suppose. Now let's declare table new int 20, let's suppose 20 with the size. Then what we have to do is we have to create the object of hashing. No, hash, I use only hash is there. Okay, hash is equal to new hash. Now this constructor takes this array and this table. Okay, we have to pass array and the table. Okay, let's write it clearly. int. Okay, now we are passing this. Now what we have to do is we have to call this method yes dot hash func. Okay, now we have to pass the prime number. Let's suppose this is 30. Okay, so in this way we can hash the values to the table. Now let's suppose we have to sort yes dot was the find was the method find. Now let's suppose 18. Now it will find the position of 18 and display the position. Okay, so in this way we can implement this hash class. Okay, this is a very simple concept. This method is called division method and this is a very fast method. In case of the division method, we will be using the big prime number to divide the list of the numbers. Okay, thank you very much for watching. Thank you very much.